and expressions, okay, section 1.1. And so first of all, we need to do some definitions. An expression is a sum and or product of numbers. So basically an expression is something that doesn't have an equal to sign. Okay, it's like half of an equation. Okay, a variable is a symbol used to represent numbers or values. Okay, you can use any sort of symbol. Generally, we use a letter. We use like X. We use like N. Okay? A term is a number, variable, or a product of or quotient of numbers and variables. So in this example, 2x plus 4, how many terms do I have? How many terms do I have in 2x plus 4? Close. I have one term right here, and I have another term right here. So this is actually two terms. My first term is 2x. My second term is 4. And so we can go ahead and combine those with addition, and that whole thing is what we call an expression. That whole thing is what we call an expression. Okay, so that's what we're going to be looking at today. So if you didn't quite get done writing down, don't worry, I'll come back, leave a spot, and we'll let you go ahead and finish writing those down. And so now, this says some more terms, and these are kind of things that you kind of already know, and that's a factor and a product. So first of all, factors are quantities being multiplied. Factors imply multiplication. A product is a result of a multiplication problem. And so what I have down here are all the ways that we can write multiplication problems. We have xy, that means x times y. We have x dot y, we know that means x times y. We have x times a parentheses around y, that means x times y. We have a parentheses around x and then y, that means x times y. And then parentheses around each of them, that means times. So that's all the different ways that you can represent a multiplication problem. Alrighty, next are powers and exponents. So first of all, a power. We have x to the nth power. It's written that way. So if I had an example like this, that would be what? X to the third power, or you might hear it referred to as x cubed. Okay. Then we have an exponent, which indicates the number of times the base is used as a factor. So we know that this 3 means that I've got x times x times x. I have 3 x's, right? That's what the exponent tells you. It tells you how many of something that you have. And then we call x, in this case, the base. So, for example, if I had this, what would that mean? Yep. 5 times 5 times 5 times 5, and you would actually be able to calculate that. So that's a little bit about powers. So today we're going to be combining powers and also expressions. And so first of all, it says write a verbal expression for each algebraic expression. So basically, you need to tell me, if I were to say that, what am I going to say? So if I look at this, what is this read as?
2x to the power of 4.
Close. Okay, not 2, what is it?
X
3 times x to the 4th. I mean, isn't that what we have? 3 times x to the 4th? So with that in mind, what's this next one going to be? 5 times z to the 2nd plus 16 will work. There's another way I could do that. Okay. We'll see how well you get this one. Okay, let's look at that. The sum of 5 times z squared and 16. Because what do we know sum means? Plus, right? So you could do that. You could even do 5 times z squared plus 16. The sum of 5 times z to the second power plus 16. So do you see all the different things you can have? All right, let's look at the next one. How do I read this first part, or this first term?
1/2 times a.
Okay, 1/2 times a. Could I just say 1/2 of a? Right? What would be next? Minus 7/2 of b. Okay, thinking back to what I did on the second one, what would be another way I could do that? Maybe like this second example.
The difference.
The difference of, good. The difference of 1/2 of a and 7/2 of b. So there's multiple ways you can write these and still get things correct. So any questions over those three? Something that just doesn't quite make sense. Okay, so let's go ahead and look at this. Now these should all be review for you. Addition, keywords, more than, some, plus, increased by, added to. Now there's actually a chart in your book that is this exact same chart. Okay, so if you get stuck, go ahead and refer back to that. Subtraction, less than, subtracted from, difference, decreased by, and minus. Those words all indicate subtraction. Multiplication, there's not as many. Product of, multiplied by, times, and of. And then last but not least, division. Yeah, all you have is the quotient of and divided by. Another thing that would be a division would be like a fraction. Okay, so it says write an algebraic expression for each verbal expression. A number x more than 6. Somebody tell me what that would be? Yeah, okay, so what should I write? What would be an algebraic expression for this statement? Okay, so how about that? Okay, that's the same thing. So basically we're doing the reverse. They're giving us the words, we're now writing an expression. So let's look at this next one. 10 less than the product of 7 and k. Okay, now I'm going to give you a key. Whenever you have this word right here, less than, it means subtraction, but this is what you're going to do. When it says 10 less than, you're going to leave a space and then you're going to put minus 10. Okay, because less than means you have a quantity and then you take that away from the quantity. Okay, so now I'm taking 10 less than the product of 7 and k. So the product of 7 and k, I'm going to now put in this spot. So what is the product of 7 and k? 7k, right? The product of 7 and k. And so this is how you would write 10 less than the product of 7 and k. Whenever you see that less than, you always got to leave a space and then put it after. All right, 2/3 of the volume V. So how can I write 2/3? 2/3. Of the volume V means you're going to do what? Times. So it's just going to be 2/3 times V. Okay, this should be review, right? You guys have seen this before? Okay, we just have one more slide to go for today, and these are some word problems here. Mr. Martin ordered 250 keychains printed with his team's logo and 500 pencils printed with their address. Write an algebraic expression that represents the cost of the order. Okay, so let's think about that. I have 250 keychains, right? And they're going to cost a set amount. So let's just say their cost is K, just for the keychains. What would the cost of the pencils be? 500 P. What am I going to do with those two amounts to find the total cost or what I'm going to owe the company? Add them. There you go. That's all you do. Okay, you don't have to figure out anything more than that. Let's look at the next one. Mr. Hanson purchased some groceries that cost D dollars. He paid with a $50 bill. Write an expression for the amount of change he will receive. So what would be an expression I could use?
50 minus M.
Okay, you're right. Let's do 50 minus what they tell me in the problem, though. What do they tell me in the problem? D. Okay, so 50 minus D. So there would be your expression for that. Okay, any questions over this? All right, then for tomorrow, this is what I need you to do on pages 7 and 8. So we're now on 7 and 8. We're no longer on the P pages. Section 1, pages 7 and 8, I need you to do 12 through 34, the evens.